Previously, you've been looking at continuous random variables and their probability density functions. Now, we're going to look at some cumulative distribution functions, like this. So, here is the probability density function for something. And if you remember rightly, to find the probability underneath it between two numbers, you would have to find the area underneath the graph like this. And that's your probability. Now, we're going to look at the cumulative distribution function. So, for this one, up to this point here, there's no probability. And what's going to happen is you're adding up all the individual bits of probability as you go along. So the line's going to keep rising as you add in more and more bits of area from this graph until you get to the whole of the curve being included. So you've added up all of this area. At which point we should be at 1, because all probabilities add up to 1. And we're not going to go down again, you're going to stay at 1 because it is cumulative. Which means if I took a point like, say this point here, whatever point, so let's say this is -2, okay? Reading off the axis here, this is a probability that x is less than or equal to -2. It is the summation of all of this area on your probability density function. So use a capital F for the cumulative frequency. So the x value is the same as saying the chance that x is less than some random value. So in this example, that x is less than -2, and you can write this as the function of -2. And we define this as the area between -infinity and -2 of this curve. So we find our cumulative distribution function by integrating our probability density function. To go from a PDF to a CDF through integration. And obviously conversely, you can work backwards by differentiating. So to get from this graph to this graph, you integrate this function to give you this one. So this function is what results from integrating this one. Let's look at a couple of properties. The first one being that this graph will always end at 1. Because it's a summation thing, they all add up to 1. That the line has no breaks in it. Okay, it's a continuous solid line, and that, so there's no breaks, and that there is no downward bits. So they can only be rising or horizontal or straight or flat. Okay, it can't go down again. You can't take off probabilities, getting add on to it. Okay, so if you've got a function like this, oh yes, the other property of course being that all values are going to be between 0 and 1 inclusive. Right, so you've got something like this. To turn this into your cumulative function, we're trying to find out the chance x is less than or equal to 0.5. So you saw this previously. If you're trying to find that, we can write this as our cumulative function up to 0.5, and to get that to integrate between -infinity and 0, which is 0 in this case, and add on to that between 0 and 0.5, so this section. So you can go ahead and finish off integrating this and find me the value of the cumulative function at 0.5. So to do that, you're integrating both sections and calculating the values. Which gives us 0.125 when you calculate it. Right, I think the next video, we'll stop this one here, and we'll look at defining a function fully.